Welcome to our lecture online. Now we're going to talk about pulleys, and there's so many different combinations of pulleys that we can encounter. We're going to do several videos on that. But let's start with this basic principle of pulleys. First of all, pulleys are used to gain mechanical advantage in two ways. One of them is that you can redirect the force required to lift an object. So instead of lifting an object like this, you can lift it by pulling on something. And secondly, you can arrange pulleys in such a way that the amount of force required to pull an object up is less than the weight of the object itself. And it depends how the pulleys are arranged. So here we have four different arrangements. Here's the most simple arrangement that we can have, which is called the Atwood machine. Notice the object hanging from the pulley here has a weight of 100 newtons, and the question is how much force is required to pull this weight up. Well, it turns out one of the things that you can do is you can draw a free body diagram around the object that you're pulling up. And if you do that, you can see that there's only one rope or one cable that's holding the weight up of the object. And so there's only one place where this object is being upheld, and therefore the amount of force required to hold this up against gravity has to be equal to the weight because there's only one. And so therefore you know that this requires 100 newtons of force. Now, another principle of pulleys is that if there is a cable or a rope going around the pulley, that the force or the tension on one side of the pulley must equal the force or the tension on the other side of the pulley. Now, that's of course only true if the pulley does not have any mass, so to speak. With other words, we can ignore the moment of inertia. And secondly, the pulley doesn't have any friction. Now, that's of course never the case. Pulley always has friction. There's always some moment of inertia. But if we can consider them to be so small that we can ignore them, then we don't have to worry about it. And so in that case, if the tension here must be equal to the tension there, then the force here must be 100 newtons. And they have to be equal, so therefore it's 100 newtons. So there's no advantage as far as the amount of force required. You simply can redirect the force, and it's easier because you can pull down on it to pull the object up rather than have to lift it up. On the second combination here, we have a second pulley. Again, if we draw a free body diagram around the pulley that holds the weight like this, you can now see that there's two cables or two ropes that are holding up the weight of that. And if we assume that the force or the tension is the same on both sides, and again, the reason why we can assume that is because that's one of the rules of pulleys, that if the pulley has no mass and no friction, that the tension on one side of the pulley has to be the same as the tension on the other side of the pulley. So since the tension has to be the same and they have to add up to 100 newtons, you know that this has to be 50 newtons, and therefore this has to be 50 newtons. Then you come up here and you realize that this rope right here is the same as the rope on the other side, and therefore the tension here must be the same as the tension there. Therefore you know that this must be a 50 newton force required to lift it up, which means that you only have to pull up with a force of 50 newtons to lift an object of 100 newtons. One of the things that happens though is that you'll have to move this twice as far to move this up a certain distance. For example, if you want to lift it up 1 meter, you'll have to pull down on the rope by 2 meters to make it lift 1 meter. Going on to the third pulley system right here, now we have 3 pulleys, and if you draw a free body diagram around this portion of the pulley, you can see that these 3 ropes are holding up the weight of 100 newtons. And then if you use the principle, let me go ahead and mark that here, so we have this one, and this one. And notice that the tension here must equal to the tension there, so those must be equal to one another. And you know that the tension here must be equal to the tension there because that rope goes around the pulley, which means that all 3 must be equal. Therefore, they each carry a force of 33 newtons. So 33 newtons there, 33 newtons there, 33 newtons there, which means that since this has to be equal to the tension over here, the force here is also 33 newtons, which means you only need 1/3 the force equivalent of the weight of this object to pull the object up. Which also means that if you want to lift this up 1 meter, you'll have to pull down on the rope by 3 meters. The last combination here, there's 4 pulleys. Again, what we can do here is draw a free body diagram around this portion. Let's do that right here. Oh, let me use the black pen. So I'm going to draw a free body diagram like this. And again, we have to assume that the pulleys have no mass, so that they do not play a role in the weight being held up by the pulleys. And you can see here that there's 4 places in which the weight is being upheld. You're holding a weight of 100 newtons. Notice that this tension must be equal to this tension, and this tension must be equal to this tension, and this tension must be equal to that tension, so they all must have the same force, the same tension, 25 newtons. 4 times 25 is 100. So this one here is 25 newtons, 25 newtons, 25 newtons, 25 newtons, and of course the tension here must be the same as the tension over there, so the force here must also be 25 newtons, which means that if you want to lift up this weight by 1 meter, you have to pull down here a distance of 4 meters to lift the weight up 1 meter into the air. So that's how we can take a look at these types of pulley systems. You can see the mechanical advantage comes in that if you have more pulleys connected like that, you have to have less force to lift up an object. That's why we use pulleys.